Hello again and welcome to Cambridge Advanced Level Mathematics. In today's lesson, we are continuing with the techniques of integration, but this will be our last video on techniques of integration. In our next video, we'll go back to our normal procedure of solving past examination questions. Today, we want to deal with a very powerful technique called integration by parts. Integration by parts. How does integration by parts work? Well, it starts with the idea. It starts from the idea of the product rule. Remember, when we want to differentiate a product, UV, we have d dx of UV is equal to v du dx plus u dv dx. That is the product rule. We dealt with in previous videos, and so that's how it looks. Now let's manipulate it a little bit and take this term to the side. So we have d dx of uv. Sorry, not vu. Let's keep it in that order. uv minus v du dx is equal to this term here, u dv dx. Right. Let us now integrate everything with respect to x. So we have the integral of, let me write this in blue to highlight something, of d dx of uv in brackets, and let's put this in brackets here. We have to integrate with respect to x minus the integral again of v du dx, again in brackets there, of course, with respect to x, is equal to that there, the integral of u dv dx, again with respect to x. Right, let's look at this term by term. All right, so here we are integrating the derivative, because d dx of uv is the derivative of uv. Now we are trying to integrate the derivative of uv. So the integral will give us back our uv. So this simply becomes uv. Here, there. This is the derivative of uv, and we are integrating it, so it gives us back our uv. So, and then minus here, of course, that remains as it is. It remains integral of v du dx is equal to integral of u dv dx, of course, with respect to x. Let's keep the notation accurate with respect to x there. Sorry about that. Okay, so there is an equal sign here. Right, let's quote our formula and put it nicely on the board. Let's write it here. We can get rid of the product rule. We all know that. So let's put now our integration by parts rule. It says, I'll put this one first there, the integral of this u dv dx with respect to x is equal to uv, this one here, minus the integral of v du dx with respect to x. Okay, first let's clear the board. the way this thing works, or when it works, or when we use it, is when we are trying to integrate a product. And what we do then is we want to convert it into a form where if we differentiate, if we let one of the functions be u, and we differentiate that u, it just changes here into something which is a constant. And our v, which remains, multiplied by the constant here, is integrable, easily integrable. So let's look at a couple of examples to see how this works. Let's start with something very, very simple. Example number one is the integral of x cos of x dx. Now, we want to integrate this by parts. So we have to let one of these, the function, the product x multiplied by cos of x, let's call them u, v. But we don't know which one, we haven't decided which one we're going to call u and which one we're going to call v. So which one should we call u? We want to take the function that we call u to be the one which, when we differentiate it and it comes over here, it's just a constant. So let u be equal to x. Now, if u is equal to x, what is du dx? Du dx is equal to 1, because du dx of x is 1. So if this is u, this has now got to be this term here. So dv dx, we have no choice. We have chosen u, we have no choice. This has to be that now. dv dx is equal to cos of x, which means v itself is equal to, integrate that, we get sine of x. Before we go any further, let's clarify this. We called this one, this is what we called u, the x there. And this is what we called dv dx. Okay? Right. Let's put in all this into our formula. The formula says this one here, x cos of x dx, is equal to uv, which is uv, which is x sine of x, minus what is v, integral of sine of x. What is du dx? It's 1 dx. So now we are just left with sine of x to integrate, and that's easy. So we now have x sine of x minus, of course, the integral of sine of x is minus cos of x. So combined with this sign here, it becomes a plus cos of x plus c, of course. This is an x, This is an x. Right. So this integrates to x sine of x plus cos of x plus a constant. Let's experiment with this and see what happens if we, instead of making this one u, we made this one u. Let's see. So let u equal to cos of x, which means du dx is equal to minus sine of x. So if we have made this one u, then this one has to be dv dx. So therefore, dv dx is equal to x, which means v, integrate that, is half x squared. Let's put everything inside our formula. We want our uv, so it's the integral of x cos of x dx is equal to our u is that, our v is that, so it's half x squared cos of x, that one there, minus the integral of, what is our v? Our v is half x squared. Our u is now our u, what did we do there? Wait a minute. Our u is that, we want our du dx is that, yes, our u now du dx is minus sine of x. Remember, this is v du dx. Of course, with respect to x, simplifying that, we have half x squared cos of x. This minus and that minus becomes a plus, and we have a half inside, which is x squared sine of x dx. This looks like a deeper pit than we were before we touched anything. So we got ourselves in more trouble than we were at the beginning. So the way you choose your u can make things simpler or can make them even more difficult. Okay? Let's look at our next example. Our next example. It says integrate 3t e to the power 2t dt. Again, we need to choose our u in such a way that when we say du dx or du dt in this case, the du dt becomes a constant. It looks like this is a good candidate. So let u equal to 3t, and du dt, of course, du dt is equal to 3. Since this is u, this will have to be dv dx. So dv dt, is equal to e to the power 2t, which means that v itself is equal to half e to the power 2t. Plugging everything in, we have, that's our v, that's our t, our u, sorry. So we have 3t over 2e to the power 2t minus the integral of our u, our v is, of course, half e to the power 2t. Our du dt is 3 dt. So that gives us 3t over 2 e to the power 2t minus, of course, the 3 and the half, we can write it there, 3 over 2 integral of e to the power 2t dt. I just took the 3 and the half outside there. So finally we get 3 over 2 t e to the power 2t, which is that one there. When we integrate this now, we get the 2 must come down, minus 3 over 4, because that becomes a half as well. 3 over 4 e to the power 2t. That is your integral. The lesson, again, is to choose your u in such a way that when you get your du dt, it becomes a constant. All right? Now, we want to deal with something that involves us repeating the integration by parts process. Our next example is integrate with respect to x squared sine of x dx. All right. Let our x be x, our u be x squared. So u is equal to x squared, meaning that du dx is equal to 2x. Now, if this is u, then this must be du dv. Sorry, dv dx. So dv dx is then equal to sine of x, meaning v itself is equal to minus cos of x, is equal to minus cos of x. Putting into our formula, we have x squared sine of x dx is equal to, we want our uv, there is our v, there is our u, so it's minus x squared cos of x, and minus the integral now of what is our v. Our v is that which is negative, and our dx is 2x. Du dx is 2x. So it becomes minus 2x cos of x dx. Remember, this is our du dx, and that is our v. Of course, we can simplify that to, this is equal to x squared minus x squared here, cos of x. This becomes a plus with the two negatives, plus 2 integral of x cos of x dx. We still need to integrate that. So let's deal with this. I'll put this in our, let's put this in a special bracket there. We need to deal with that. This we have done. We are done away with it. So let's deal with what is inside the blue square bracket. Right. Let's remember our integral is that. Let me write it there. So it's because I want to use this space here. So we can write this was the integral of x squared sine of x dx. So let me just and remember, it gave us that. Oh, so no, we can write it, the integral of x squared sine of x dx. So we can get rid of this part here. So there we are, there we are, there we are. Now we need the blue part. So we have the integral of x cos of x dx. Now let x equal to u equal to x, sorry, u equal to x, so that our du dx is equal to 1. And of course, this becomes our dv dx. So dv dx is equal to cos of x, meaning v is equal to sine of x. So plug it into the formula, we get this becomes equal, this now becomes equal to our uv. V is that and that. So it's x sine of x minus the integral of our v is sine of x, our du dx is 1. So it's just sine of x dx here. And this simplifies to x sine of x minus this integral of sine of x is minus cos of x plus this one, it becomes cos of x. Right. Let's put everything together now. Let's put everything together now. So we know that we can say our integral of x squared sine of x dx is equal to this part here, is equal to x squared cos of x plus 2 multiplying this, because this, we have simplified it to that. So plus 2x sine of x and 2 cos of x plus 2 cos of x plus, of course, a constant c. That then, is it not possible to simplify this? We can simplify it. Yeah, it's fine. It's all right. You can stay like that. So that's the integral there of your x squared sine of x dx. The lessons to be learned here is that you have to be careful how you choose your u. Choose your u such that when you differentiate it, it converts into just a constant, so that this integral becomes just v dx. And v should be, of course, something that you can integrate easily. Of course, integration is not about certain procedures and certain steps and certain rules. Integrals come in all shapes and sizes, and you have to look at it and say, how do I panel beat it into a shape that becomes standard or whatever it is? And which method to use is also a matter of experience. You don't just get an integral and this is what you must use. There are all kinds of methods and ways of substituting this to get it into that, etc., etc. But the answer to all those things is practice and practice and practice and practice. I always give this very important example to my students. You can sit on the driver's seat and watch somebody drive every day with you to work. You see him change gears, you see him accelerating, you see him start the car, you see him brake. But until you sit there by the driver's seat and change the gears yourself and accelerate and put on the brakes, you are not a driver. So you cannot learn mathematics by seeing someone solve problems in mathematics. The way to learn mathematics is to do it yourself. And you never get to a point where you say, now I know everything. I myself am also a student of mathematics. You learn every day by practicing and practicing and practicing and practicing. And guess what? When you do it consistently, you begin to develop a love for mathematics. And once you love it, everything falls into place. Till next time, thank you very much. But please remember to subscribe and press the like button. It does help us a great deal. Thank you very much indeed. See you next video.